Okay, a couple definitions here. An equation is true if the expression on either side of the equal sign are equal. And that's... An equation is true if the expression on either side of the equal sign are equal. And then down here's an example of a true equation. So an example of another true one would be 2 plus 5 equals, that's 7. 2 plus 5 equals 3 plus 4. This is a true equation, isn't it? Because this side is equal to this side. Okay? Look what it says. An equation is false if the expressions are not equal. Alright, so it's false if the expressions are not equal. So give me an example of false, Carissa. Just what's your favorite number? Okay, 3 plus your second favorite number. 5 equals, we got to make this false. So what does that equal? 8. So we got to have something on the other side that is not equal to 8. So is 3 plus 5 equal to 6 plus 4? No, it's not. So this is called a false equation. They're not equal to each other. That's all. A true equation is when both expressions are equal to each other, and a false equation is when they're not equal to each other. That's pretty straightforward, isn't it? An equation that contains one or more variables is called an open sentence. An open sentence contains one or more variables. So an example of open would be 2x plus 5 equals 25. It's got one or more variables in it, so it's open. Questions? All right, and then right down here, do you see how the book now explains everything that I just explained? Yeah. 24 plus 18 is how much? Quick, you got a blue thing on your desk. Add it together. 24 plus 18. 42. Good. What's 20 plus 22? Good. True, false, or open? True. All right. Look at the next one. 7 times 8 equals 54. True, false, or open? Why? 7 times 8 equals 56. Very good. And then look at problem 1C. Why is this open? Very good. Because by definition, an equation that contains one or more variables is called an open sentence. Well, it's got a variable in it, so it's open. Okay? Now, didn't the book just say everything I just said? It does that all year long. Okay? The book says everything I'm getting ready to say, or everything that I say. Or I say everything the book says. So let's look down here along the bottom. Is the equation true, false, or open? 3y plus 6 equals 5y minus 8. Somebody raise your hand and tell me what it is. Taylor. Open. Good. B here. 16 minus 7 equals 4 plus 5. Is it true, false, or open? Brandon.
False.
Why?
Because 16 plus 7 is
Hey, look at it one more time. So it is true. Very good. Agreed? And C, Madison. 32 divided by 8 equals 2 times 3. True, false, or open? Why? $32 divided by 8 equals. Really? You got a calculator on your desk. Oh. 32 divided by 8 equals 4. What's 2 times 3 equal? True, false, or open? False. Very good. Those calculators, I got them for you so that you could use them. Okay? So that you could use them. Solution of an equation containing a variable. Solution. Probably a good time to write a definition down, maybe in your own words. Solution is the value of the variable that makes the equation true. Solution. Value of the variable. Value of the variable. That makes the equation true. Alright, so now they're going to give you a value for the variable, and they're going to ask if it is a solution to an equation. So how do you find out if 6 is a solution to 32 equals 2x plus 12? Dan? Plug it in. You take the 6 and you put it where the x is. So does 32 equal 2 times 6 plus 12? Does 32 equal 12 plus 12? No, it doesn't equal it. Is it a solution? No. X minus 6 is not a solution. Alright, that's what they're asking there. Is the value for the variable a solution? Is m equals 1/2 a solution of the equation 6m minus 8 equals negative 5? I know how much you guys love fractions. So you're going to take 6 times 1/2. You're going to subtract 8 from it, and you're going to see if it equals negative 5. You already know it, don't you? What's 6 times 1/2? 3. Because 6 times 1/2 is the same thing as 1/2 of 6. So 3 minus 8 does equal negative 5, doesn't it? Alright, so that works. So is it a solution?
Yes.
Yes, it is. Writing an equation. An art student wants to make a model of the Mayan Great Ball Court in Mexico. The length of the court is 2.4 times its width. The length of the student's model is 54 inches. What should the width be? When you get to these word problems, and I know these, you like these just as much as you like fractions, don't you? You guys love word problems. Look at, you've got all these words, right? But a lot of the words are just in there to make the problem bigger. There's no information in them. Who cares if it's the Great Mayan Ball Court in who cares, right? So all of this, that, and all of that is complete garbage, isn't it? Don't need it. What you do need is the length of the court. 2.4 times its width. That's important. All the other first sentence is not important. It's garbage. The length of the student's model is 54 inches. What should the width be? So what are we trying to solve for here? The width. Does everybody agree? Because the question says, what should the width of the model be? So look how they set this up. the length is 2.4 times the width. All right? The length is 2.4 times the width. Let W equal the width of the model. Well, where'd they get this 54 from? They got it from the length of the student's model is 54 inches. So right here where it says the length, they replaced it with a 54. So 54 is in math means, what does it mean? Equals, right, Venus? You agree? Is means equals. The length, the 54, is equals 2.4 times the width. 2.4 times W. Okay? Simple enough? And then how would you solve that? Yeah, because to us it looks like this. 54 equals 2.4 W. So divide each side by 2.4. And in your little blue thing on your desk, what do you get? What is it?
22.5.
22.5 equals W. Now listen, guys. That is a typical end of course question. Was it very hard?
No.
When you first glance at it, were you like, oh God, that's a big question? Didn't we just eliminate half the question because it's garbage? And isn't the answer in the rest of the question? The answer was in the rest of the question. The length is 2.4 times W. It's right there. The answer's in the question. So if what you have to do is you have to overcome your fear of all these words being there and learn how to just read it, scratch out what you don't need, pull out the information that you do need, because the answer is in the question. Okay? Alrighty. Let's take a look at page 64. Tell whether each equation is true, false, or open. That's determining if one side is equal to the other side, right? If they're equal, what is it? True. If they're not equal, what is it? If there's one or more variables, open. Good. Now, tell whether the given number is a solution to each equation. What does that mean to do? Tell whether the given number is a solution. That means to substitute, doesn't it? Uh-oh. Substitute. Alright, that means take the negative 3 right here. Substitute it where? In for B. And see if the equation is true. If the equation is true, is it a solution? Yes. If the equation is not true, then it's not a solution. Okay? And then here on 23 through 26, the sum, what does sum mean to do? Add, of 4x and negative 3. So how would we write that? 4x plus negative 3 means equals 8. And all it says to do is to write an equation. Okay? So they start off with 23 and 24, where it's very straightforward. They get right to the facts. And then on 25 and 26, they throw some more words in there. But make sure you go through the problem and find out what's important and pull it out and use it. Okay? So you've got, is that 10? Nope, that's 7 through 26. Okay? 7 through 26 on page 64. Page 64, you're doing 7 through 26.
We'll just try F and T.
Yeah, that's fine.
Yeah, you